let's talk about another way to measure an angle using a unit that's different from degrees. This other unit is referred to as radians. You will notice that radians kind of sounds like the word radius, and it is based on the radius of a circle, the unit circle, which we now know has a radius of 1. And so some angles are measured in degrees and some are measured in radians. So you need to be able to convert from one measurement to another. So if you're given an angle that is in degrees and you want to go 2 radians, you're going to multiply the degree measurement by pi over 180. And then you're going to simplify. So let's start with 30 degrees. So if I take 30 degrees multiplied by pi times 180. If I want to make this a fraction, I just put it over 1. So that means I have 30 pi divided by 180. Now, first I want to do this as a simplified fraction, and then I'm going to do it as a decimal. So let me pull up my calculator here and turn it on. So if I have the fraction 30 divided by 180, and I do math enter to make it a fraction, that gives me the fraction of 1/6. Now I still have the pi there. And notice I did not enter the pi into the calculator. So I have 1 pi divided by 6. Now, that's fine. That's a common way that the angles are going to be measured. But I could also say, well, what is pi divided by 6? So there's a pi key on the calculator. So if I take pi divided by 6, notice it's a decimal and it's going to keep repeating. So I have 0.5235. So let's go 4 decimal places. This 9 tells me to round this 5 to a 6. So I'm going to have approximately 0.5236. That's a rounded value. These are radians. That's if I multiply it out and actually do the pi over 6. Sometimes the answers will need to be as a simplified fraction. Sometimes they will need to be as a decimal. All right, let's work with 45 degrees. So 45 degrees times pi over 180. That's going to give me 45 pi over 1 times 180 is 180. Again, I want to put this fraction in lowest terms. I'm going to come back to my calculator here, and I'm going to have 45 divided by 180. I want the answer as a fraction. So that's going to be 1/4. Still have the pi there. So that's going to be pi over 4. Now, that is a radian measure of an angle. You've seen pi over 4 before. You've seen pi over 6 before. Let's find the decimal equivalent to pi over 4. I take the calculator and enter pi divided by 4. 0.785, and we're going to round this, so 0.7854 radians. So 0.7854. Or the exact answer is pi divided by 4. Now, 30 degrees was pi over 6. 45 degrees was pi over 4. I'm hoping by now that you're already guessing that 60 degrees is going to be pi over 3. If you're not, pretend like you were. So 60 degrees times pi over 180. This is going to be 60 pi divided by 180. You can use your calculator to put 60 over 180 in lowest terms. Or you can use the mental math and say, the zeros would actually divide out. And 6 goes into 18 3 times, so this is actually pi over 3, which is what you were expecting anyways, I hope. Now, pi, the value of pi is 3.14159, and it continues on forever and ever. One of those special numbers. It's irrational. It does not end. It does not repeat. If it's 3.14, and I'm going to divide it by 3, it's going to be 1 point something, I'm thinking. Alright, so let's go to the calculator here, and let's do pi divided by 3. Well, 1.047, this 9 says to round that 1 to a 2. 1.0472. So 1.0472. Because I'm rounding, I use these little approximate symbols. So 60 degrees is either pi over 3 radians exactly, or approximately 1.042 radians. So let's scroll down and let's figure out, let's do a couple more here. How about 180 degrees? I need a new color. So 180 times pi over 180. That would be 180 pi over 180. Hopefully your math skills are kicking in and you're saying, well, 180 over 180 is just 1. So this answer is just going to be pi. Again, you can pick your calculator up and figure out, or you can say that would be about 3.14. I just really want to make sure that I'm not losing my mind here. 3.14159 would round that to be 1/6. So 3.1416 radians. Now, let's look at one more.
The representatives from Myers who are here doing the vaccination.
Let's look at 315 degrees. So let's change colors again. Let's go to pi over 180. Nothing like being at school and the announcements come on. I'm not sure if you could pick that up on the video. We're going to keep on rolling though. So this is 315 pi divided by 180. Now you could ask yourself, 315 over 180 in lowest terms. I'm not going to be able to simplify that in my head quickly, so I'm going to use my calculator. But I do want to realize that 315 is more than 180. So I know my answer is going to be more than 1 pi. Let me get some of this off the screen. So I have 315 divided by 180. I want that answer as a fraction in lowest terms. 7/4. So this is going to be 7, I still have the pi, 7 pi over 4. Again, it's in one of our angle families. And the decimal equivalent to 7 pi over 4 is 7 times pi divided by 4. So about 5.4978. So approximately 5.4978. So we have converted all of these angles to radians. Now let's look at the unit circle. 30 degrees, pi over 6. We had that one. 45, pi over 4. We had that one. 60, pi over 3. We had that one. So then after 60, let's scroll back up, we did 180 and we got pi. So let's scroll back down and see 180 is right here, and there's the radian measure pi. And then we did 315 and we got 7 pi over 4. So you're asking yourself, if If all these are on the circle, why do I need to know how to convert them? Remember we talked earlier that these are not the only possible angles drawn on here. These are just the most common ones, the ones that occur in special right triangles. There's an infinite number of angles on this circle. So I could draw another angle. Let's look at this one, which is at 0 degrees. 0 degrees, 0 pi. 360 degrees, 2 pi. Same spot over here. So let's look right here. 0 times pi over 180 is going to give us 0 over 180, which is just 0. So that's an easy one to remember. 360 times pi over 180 is 360 pi divided by 180. 360 divided by 180 is 2, so that is 2 pi. Now, if I multiply 2 pi out, remember pi is 3.14, so 2 times pi is 6.28, and let's go a little bit more accurate here. 6.2832. 6.2832. Now, this kind of made sense. 315 degrees was 7 pi over 4, or 5.474978 radians. 5.4 something. That was here. So this was about 5.49 radians. This is 6.28 radians. Makes sense. Close values there. What if you have an angle that's not drawn on the unit circle? So let's find this angle. Let's say if we started here, which is where all the angles begin, and we came back to here, and we always go counterclockwise. So I'm just estimating an angle over here. It is somewhere between 180 degrees and 210 degrees. So let's say 200 degrees. So if I have an angle that is 200 degrees, and I want to know how many radians that is, I still just multiply it times pi over 180. So I'm going to have 200 pi over 180, and you can either simplify mentally or you can use your calculator. 200 divided by 180, I lost a 0 there. 200 divided by 180. The fraction in lowest terms is 10 over 9. And I still have my pi. So this is 10 pi over 9. Notice that when I use the pi symbol, that means it's an exact answer, so I can use equals. When I have to round it, then I have to use the approximately, and 10 times pi divided by 9 is 3.49. Now let's see if this makes sense on our circle. 3.49 radians. We don't, like degrees, we use the little circle to represent degrees. Radians, you just write out the word radians. 3.49 radians was 200 degrees. Well, here's our angle, and we estimated this to be 200 degrees. Remember, pi is 3.14 radians, and this is 3.49. So it's a little bit further, so it's a little bit more. Makes sense. Any angle given to you in degrees can be converted to radians. So any angle given to you in radians can be converted right back to degrees. Now, I'm hoping that you're getting a little faster here and you're starting to see some connections. Pi over 6, you can look at the unit circle, or remember, this should be 30 degrees. So let's see what happens here. When you're going backwards, you multiply by 180 over pi. When you're going from radians to degrees. So 180 divided by pi. And look what happens here. We have, let me go ahead and multiply show you this one. 180 pi over 6 pi. Pi divided by pi. Anything divided by itself is 1. So the term you all probably use is cancel out. 180 divided by 6. 6 goes into 18 3 times, and we have a 0 there. 30 degrees. We knew that answer was going to be 30 degrees because we just converted 30 to pi over 6. So when we convert pi over 4, I bet you know that we're going to get 45 degrees. Now, if you want to, as you're getting faster, you can say, well, these pi's are going to cancel. I'm going to have 180 divided by 4. So that's going to be 45 degrees. Pi over 3 times 180 over pi. Pi's are going to cancel. 3 goes into 180 60 times. These are common angles, and I'm hoping that you're starting to recognize those values now. Let's look at pi over 2. It's in radians. I want to convert it to degrees. It's so nice and convenient that the pi's cancel. 180 divided by 2 is 90 degrees. Now let's go back up and look at our circle here. Pi over 2, 90 degrees. And again, if it's a test, you may be asked to convert from one of the common angles that we use, or you may be asked to use an angle that's not actually drawn on the unit circle. Alright, let's do a couple more examples here. You want to convert 5 pi over 6 to, I can't talk and write at the same time, 2 degrees. So we're going to do times 180 over pi. Pi's are going to cancel out or divide to be 1. So this time not quite so easy, depending on your mathematical skills here. The numerator is going to be 5 times 180. So you may want to multiply that out. 5 times 180, which is going to be 900. And then the denominator is just 6. So maybe you're good at dividing, maybe not. 900 divided by 6 is 150. 5 pi over 6. Is that on our unit circle? Let's scroll back up and see. 5 pi over 6, 150 degrees. So we're on the right track here. Now this last one is 4 pi over 3. Let's cheat. Let's see what our answer should be to begin with. 4 pi over 3, down here in the third quadrant. Our answer better end up being 240 degrees. Let's make sure that we can get 240 degrees. We're going from radians to degrees. So we're doing 180 over pi. Pi's are going to cancel. So I have 4 times 180 divided by 3. 4 times 180. Your calculator's only as smart as the person putting the numbers into it. Surprise, surprise, 240 degrees. Now what if we were just given 1.5707 radians? We need to convert this to degrees. So I have 1.5707. I'm still going to multiply it by 180 over pi. But since this one's not written with the pi in the original problem, I can't simplify by canceling out the pi's. So what I have to do is just go to my calculator. And I'm going to do 1.5707 times 180. And then divided by, I can do it all in one step, divided by pi. And I get 89.99. How do you think we should write that? Let's do 90 degrees. And since I rounded, I better keep accurate. 90 degrees. 90 degrees is one of our regular angles. We just learned up here that pi over 2 is 90 degrees. 1.5707. If you take your calculator and you do pi divided by 2, you get 1.5707. 08 if you round. So you should be able to convert from degrees to radians and from radians back to degrees again.